The next problem that we'll talk about on the review is problem number 22, which involved figuring out the square root of 691 without the use of a calculator. To do this, the trick is to kind of group the digits by 2. So starting at the decimal point, these two digits will be together, and then the 6 will be together. And then we kind of play Price is Right. The perfect square that is closest to 6 without going over is 4. That's 2 squared. So I'll put a 2 here. And then 2 squared is 4. So subtracting, I get 291. The next thing that I do is take the number here and double it. And I need to put one number here so that 40-something times the something is as close to 291 as I can get without going over. Okay, so let's see what we get. So obviously, let's just do this by trial and error. 41 times 1, 42 times 2, 43 times 3, 45 times 5 is 225, getting close. 46 times 6 is 276. 47 times 7 is too big. So 46 times 6 looks like is the correct answer, 276. So let me put the 6 here and the 6 here for 276. So 26 point. Subtracting, I get 15 here. Then I bring down the next two zeros. Here, double the number that's here, 26. So 26 times 2 is 52. And then I do Price is Right again, 520 something. So 520 something times a something. I want that to be as close to 1,500 as I can without going over. Here, if I took 523 times 3, that's clearly too big. So 522 times 2 is 1044. So I need a 2 as my next digit. So 522. Multiplying, I get 1,044. And so subtracting, I get 456. So I get 26.2. Then I would bring down the next two digits and then continue. We know that there's going to be an infinite number of digits because it did not work out to be a perfect square. Now, why does this trick work? Well, first let's check that it actually did work. If I take 691 and take the square root of that, I do indeed get 26.2 something. Okay, now why does this work? The idea here is that when I found the 2 here, I knew that I'd have 20 something squared to be equal to 691. Okay, now let me square out the left-hand side. I get 400 plus 40 x plus x squared equals 691. Okay, now if I subtract the 400 over to the right-hand side, that gives me 291, which is the number that you see here, 691 minus 400. What's here remaining here, after I subtract the 400, would be these two terms, and I can factor an x out of that, which is 40 plus x times x. And this takes the place of what you see over here, 40 plus some number plus the next number. And x is going to be 6 point something or another. Then if I actually solve this with the quadratic equation, the idea is that here it's not going to be exactly equal, so let me get the integer x that is as close as possible to 291 without going over, which gives me the 6. Then continuing the logic, I would get the next decimal places using basically this base 10 argument for getting the next few places. So that's anyway the logic as to why that works.